Okay, in Algebra 7.6, we'll be factoring polynomials, more specifically trinomials or quadratic trinomials in the form of ax squared plus bx plus c. Or how this is different than 7.5 is the a coefficient of x squared will be something other than 1, which actually makes it a little bit more difficult in order to factor. For example, if I wanted to factor 3x squared minus 7x plus 2, I would try to factor that into the product of two binomials. So we'll just go through a method where it's kind of just plug the numbers in and test and see if they work. So you want to look at the first term here, 3x squared. I'm going to try to factor 3x squared minus 7x plus 2 into two binomials, so the opposite of distributing or the opposite of FOIL. And the first term of each binomial has to multiply to give you 3x squared. So you should know from 7.5, you have x and x, but if you multiply x by x, that's x squared. I want 3x squared. And luckily, 3 is prime, so it could only be 3x and x, or it could be x and 3x. The order doesn't matter there. But then I want to look at the last term, positive 2. Okay. And these last two terms of each binomial still need to multiply to a positive 2. So those are the numbers that I'm looking for. And then those numbers themselves don't add to the negative 7 because it's impossible to find two numbers that multiply to a positive 2 and add to a negative 7. But I have the 3x here and x. So when I FOIL things out, when I multiply the factors of 2 by 3 and 1, that's when they should add to negative 7. So I'm going to need to test certain numbers. And really, when I test the numbers, I'm going to use outside and inside of FOIL to test the numbers to see if they add to negative 7x. Because I already know 3x times x equals 3x squared. When we find the factors of 2, we should already know that they multiply to 2. So maybe you try something like 2 and 1. Luckily, there's not many combinations here. 2 and 1, 1 and 2. Order does matter here once I put the 3 in. Okay. If they multiply to a positive 2 and add to negative 7x when I multiply them by 3 and 1, really that should tell you that both of the signs should be negative. So I'm going to test this and see if it works. If you notice, I did this in pencil because I might need to change it. So again, if I FOIL this out, 3x times x is 3x squared. That's first to FOIL. Last to FOIL would be negative 2 times negative 1. That's positive 2. I shouldn't really need to check those. That's how I got 3x and x and negative 2 and negative 1. But if you test outside of FOIL, this is outside of FOIL. 3x times negative 1. That's negative 3x. Inside of FOIL is negative 2 times x. That's negative 2x. Negative 3x plus negative 2x, those add to negative 5x. So that doesn't work. And luckily, I wrote things in pencil because then now I could just switch the numbers around and see if that works. 1 and negative 2. Sorry, negative 1 and negative 2 now. So outside of FOIL, 3x times negative 2 is negative 6x. And then negative 1 times x is negative 1x. If I add those together, negative 6x plus negative 1x, or 6x, negative 6x minus x is negative 7x. That does work. So this is the correct factorization. 3x squared minus 7x plus 2 factors into 3x minus 1 times x minus 2. In my next example here, I want to factor 5x squared plus 17x minus 12. So I want to try to factor it into the product of two binomials. Look at the first term, 5x squared, and what you can multiply together for the first term of each binomial to get 5x squared is 5x and x. I'm writing that in pen because that's all it could be. If this were something like 10x squared, it could possibly be 5x and 2x, or it could be 10x and 1x. I wouldn't know for sure until I tried specific numbers. So then I would write it in pencil, because I might need to possibly erase it. And now I look at the last term, negative 12. The last term of each binomial needs to multiply to negative 12. So what that means is, first of all, one has to be positive and one has to be negative. And then I need to look at all the possible factors of 12. 12 and 1, 2 and 6, 4 and 3. There might be quite a few different combinations that we would need to try. And then Once I multiply those two factors of negative 12 by 5 and 1, then they should add to 17. Maybe you could try to play around with some numbers before we go over this together and then figure out exactly what works. If you tried and figured out exactly what works, you might be able to tell, because this number 5 and then this number 1, that the number here probably should be positive, because if I multiply it by positive 5, and then if this number is negative, I would multiply it by 1. They have to add to a positive. So really the larger number has to be positive. So maybe you fill this in, put that positive, this is negative. If you tried certain numbers like 2 and 6, those multiply to, this is supposed to be positive, negative 12. But if I multiply 5x by 6, that's 30x. That's outside of FOIL. Negative 2 times x is negative 2x. 30x minus 2x, that's 28x. That's too big. Right? And then you could try other numbers, possibly like 4 and 3. If you try that, that actually would not work. Let's try 3 and 4. So outside of FOIL, 5x times 4 is 20x. Inside of FOIL, I'm going to cross that out because that doesn't work. Negative 3 times x is negative 3x. 20x minus 3x is 17x. So this is the correct factorization of that polynomial.